Okay, 11.7 is what we're talking about today, and that's again volumes. Volumes, volume of pyramids and cones. And in 10-6, we talked about volume of prisms, and we said that the formula is the area of the base, that's what this capital B stands for, times the height. And that's how we find the volume of prisms and cylinders, because they have two bases. Well, if we're talking about pyramids and cones, they only have one base. So if I took this prism and I turned it into a pyramid like this, so it still has the base, but instead I'm chopping it up. Well, what do you think would happen to the volume? It's obviously less. We can agree that it's less than the volume of the rectangular prism. But by exactly how much? It's going to be exactly a third. So same thing for cones. If I took a cylinder and I cut it so that I made it into a cone, and by doing that I just go like this, what's going to happen is the volume is going to be exactly a third of whatever the cylinder was going to be. So pyramids and cones are pretty simple. It's pretty simple to find the volume. It's always going to be area of the base times height, just divided by 3. All right, so for a rectangular square pyramid, that means the base is either going to be a rectangle or a square. So find the volume of the square pyramid with the base edge of 9 and a height of 14, and that's important information. Since it's a square, we know all the sides are going to be the same, so all the sides are going to be 9. And then the height of the pyramid. So if I took a perpendicular line from the base all the way up to the vertex, it would be, that height is going to be 14. So there's my attempt at a picture of a square pyramid. So the first thing we're going to do is find the area of the base. So since it's a square, you just go base times height, and that's going to be 81. To find the volume, you're going to take the area of the base, multiply it by the height, and then divide it by 3, since we're talking about a pyramid. So 81 times the height, which is 14, divided that by 3, and the volume of the pyramid is going to be 378 cubic centimeters. Remember, for a volume, we use a cube. Okay, this question is a little bit different. An art gallery is a 6-story square pyramid with base area. Oh, I didn't give you a number here. Let's say that the base area is 16 acres. Okay. Estimate the volume in cubic yards and cubic feet. Okay, so for this one, it's a 6-story. This is going to be your height. And if the base area is 16, they already give you the base area, so it's already 16 acres. Since they want it in terms of yard and feet, this is for an honors question, sorry. CP, you guys have a different question, and you can find the one in your packet. Okay, so for honors, 16 acres, they want the volume in cubic yards, and they tell you that 1 acre is about this many yards. So what you're going to have to do before we start estimating volume is you need to change this base area into yards. So you're going to multiply it by 4,840, and that'll tell you how many square yards there are. Then to find the volume, what you're going to do is you're going to take this answer, you're going to multiply it by the height, which is 6 stories. So that's one conversion. To figure out the stories, 1 story is about 10 feet. So if we have 6 stories, you're going to multiply that by 10, and that's going to be 60 feet. However, we have yards and we have feet. So you need to take this and convert it into yards. And there's about 3 feet in 1 yard. So if there's 60 feet, then if you divide it by 3, that means it's going to be 20 yards. So you're going to multiply this answer times your height, which is now 20 yards, and then divide it by 3 since it's a pyramid, and that's how you get your answer. Triangular pyramids are no different whatsoever. It's the same kind of concept, so we can skip this question. I want to see if you can do this one. You can title this number 1 on your notes if you want to. Find the volume of a regular triangular pyramid with base edge length 12 and height 10. I'll give you a hint. Regular, remember, means all the sides and angles are the same. So this is an equilateral triangle, and to find, remember, the area of a triangle, or the area of the base, you're going to do base times height divided by 2. And remember, the base and the height need to be perpendicular. So you might need to use 30, 60, 90 triangles to figure out what the height of the base is going to be. Okay, so that's pyramids. Remember, the formula is just area of the base times height divided by 3. Okay, let's see. Next thing we're going to talk about cones. Remember, cones are easier because the base is always going to be the shape of a circle. So the formula is still the same, area of the base times height divided by 3. Okay, so I want to do a good one with you guys. Number 2 and number 4 are, actually number 3 is a really good one too. Number 4, this is oblique because it's tilted, but the formula is still the same. It's still area of the base times the height divided by 3. Okay, for number 2, it says find the volume, and it's hard to tell, but the 34 they're referring to is the slant height. This is the slant height, and we want to figure out what the height is. The height goes, remember, from the base, the center of the base up, the height is perpendicular. So this is what we need to figure out if we want to figure out volume, because it's area of base times height divided by 3. So we know that this radius is 16 and that this slant height is 34. So what we're going to do is we're going to think of this as a right triangle, and we're going to use Pythagorean theorem to figure out what the height is. Whoa, I don't know what that's like magic. Go away. Okay, so we're going to figure out the height by doing Pythagorean theorem. So 16 squared plus the height squared is going to equal 34 squared. And when you do your math, you'll get that the height is 30. Now that you know that the height is 30, we can find out what the area of the base is going to be. That's just pi r squared. And then to find the volume, you take the area of the base, you multiply it by the height, and divide by 3. So the volume is going to be 256 pi times 30 divided by 3. And some of you guys are going to want to go to your calculators. Stop right there. Think about it this way. What is 30 divided by 3? That's just 10. So now you have 256 pi times 10, and you can do that really, you don't need a calculator to do that. That's just going to be 2,560 pi, and that'll be the volume, so what's cubic centimeters. Okay? I should have hit number 4. Number 5, the reason why I like number 3, excuse me, says find the volume of a cone with a base circumference of 65 pi inches and a height 2 inches more than twice the radius. So we need to figure out what the radius is, and we need to figure out what the height is in order to find the volume, because the volume is area of the base. The base is a circle, so that's pi r squared times the height. So if you want to write this down in your notes for cylinders and cones, since it's always dealing with a circle, area of the base will always be pi r squared times the height of the whole cone divided by 3. Sorry, I'm going backwards a little bit. Okay, so if the circumference is 25 pi, we know circumference is 2 pi r, and that equals 25 pi. So using that formula, we can figure out what the radius is. The pi's are going to cancel each other out, and if we divide both sides by 2, we get that the radius is 12.5 inches. Okay, the height now is 2 inches more than twice the radius. So 2 times the radius, 12.5 times 2, is going to be 25. And then it's 2 inches more than that. So the height is going to be 27. Now that we know what our radius is and what our height is, we can plug it into this formula. And I get that the answer is 1,406.25 cubic inches. Correct me if I'm wrong, though. All right, the very last thing I want to talk about is what happens to the effect on surface area and what happens to the volume if you change the dimensions of something. So if you, for instance, it says in number 5 that both dimensions are going to be doubled. For surface area, that's like saying, this is like saying you're multiplying it by 2, okay? Whatever is happening to the dimensions, for surface area, you just square it. So if it's being multiplied, if all the dimensions are being multiplied by 2, you take that and you square it. So what happens to the surface area is it's going to be quadrupled. For volume, you don't square it, you cube it. So the dimensions are being changed by 2. They're being doubled by 2. So what happens to the volume? 2 times 2 times 2 is 8. So this means that the volume is going to be increased times 8. So whatever the original volume was, the new volume is going to be times 8 of that. The surface area is going to be quadrupled. So it's getting bigger by times 4. Okay, and this works for everything. For instance, let's say I take the dimensions of any shape. It doesn't have to be this oblique cone. It could be anything. Let's say that I cut everything into a third. Take all the dimensions and I divide it by 3. What's going to happen to the surface area of that figure? Well, all you have to do is, this is what I'm doing to the dimensions. I'm cutting everything down by 3. All you're going to do is square it. 1/3 times 1/3 is 1/9. That means the surface area is going to be reduced by 1/9. For volume, you cube it. So the dimensions are being cut by 1/3. So you take that and you cube it. Multiply it times itself 3 times. And you're going to get 1 over 27. That means the volume is going to be reduced by 1 over 27. Okay? And I can show you a picture of what that looks like in class, because I know that's a little difficult to understand without a real picture in front of you. All right, so we talked about, video's getting a little long, I apologize. We talked about 3 things. We talked about volume of pyramids. We talked about volume of cones. The formula is still the same. Take it and divide it, take the area of the base times height divided by 3. And then the last thing we talked about is what happens to surface area and volume if you change the dimensions.